Today I'm going to be going through a few different tools in SOLIDWORKS Simulation that can be really useful to boost your efficiency, but not a lot of people are using. So the first tool I'm going to get started off with is something that's brand new for SOLIDWORKS Simulation 2015, and that's the Load Case Manager. This is a tool that's included with SOLIDWORKS Simulation Professional and above. And what it's going to allow us to do is define primary load cases, things like dead load, live load, wind load, snow load. So you can put those in, and then afterwards we can create as many combinations of those primary loads that we want, and they're going to be linearly combined. So it's going to give us the ability to run many different situations, but without taking the time of all of those individual situations. So it's a great way to improve efficiency, and it's also much simpler to look at the results in a tabular format than to look at them by investigating the plots individually all the time. So let's take a look at what that looks like. I've got an example here. It's a little deck. I've made it using the Weldments tools in SOLIDWORKS with some lumber. And what I want to do is show you guys the setup that I currently have. Which, as you can see, has all of my components organized in a cut list. Like I said, made using the Weldments tools, so this is going to be a beam mesh. I've fixed the 4 feet. I've got a load on top that's equivalent to 10 pounds per square foot. I've got another load on top that's equivalent to 40 pounds per square foot, and both of these loads are on the exact same location, the exact same direction, and we're just going to see that this is going to be equivalent to my dead load and my snow load. So I'm going to have two different forces of two different values. I've also got a wind load coming from the side, and I've turned on gravity. Now I can insert all of these forces, and then I can run my analysis and get my results, and that's going to take a look at what happens when all of these forces are applied at the same time, which of course is no problem. And something you guys may have done before is you may have actually duplicated your study, right? Created static 1, static 2, static 3, static 4, maybe even give them descriptive names like dead load plus live load, dead load plus snow load, and looked at the individual combinations just by turning these on and off or switching the numbers around inside. The Load Case Manager is going to allow me to do all of the same things, but I'm not going to have to do it manually. I'm not going to have to create all my individual studies. Instead, I'm going to be able to use a tabular format. Now, once you create your initial study, the way to access the Load Case Manager is to right-click on the study name, and you'll have an option to turn that on. Once you do, it will show up in the simulation tree, and you'll be able to view and edit the definition. It's going to pop up here, and you're going to see that you can define primary load cases and load case combinations. So I've come in here and I've typed in dead load, snow load, wind load, 3 different primary cases, and then selected the appropriate force that goes with that description. So for the dead load, I've selected my force that is equivalent to 10 pounds per square foot. Notice that the other forces are suppressed, except for gravity. I've got that on as part of my dead load as well. For my snow load, I've turned on the force that's equivalent to 40 pounds per square foot. And then for the wind load, I've turned on the force that's coming from the side. After that, I can come and define my combinations. I've got 3 set up here. One is dead load plus snow load, another is dead load plus wind load, another is dead load plus snow load plus 2 times the wind load. And to add more, you can simply type this in and build them up in this box here simply by typing in whatever it might be that you want. Once you run this all, it's going to step through, and it's going to start off by running the dead load independently. It's going to run the snow load independently, and it's going to run the wind load independently. And so it's going to take about the time to run 3 analyses. However, it's not going to take the time to run 6. So these combinations, once these first 3 primary cases are done, are simply determined by combining the primary cases linearly, and you'll find that they run in a fraction of the time. And so afterwards, I've got my results, and I can quickly look through and see that, okay, I've got my primary load cases and I've got my load case combinations, and I've got still my simulation tree on the left where I can access my results. And so I could pull up my stress plot and see that, okay, this is what the stress looks like for all of them combined, as we saw earlier. What if I just want to look at the dead load by itself? What does that look like? And I can see that's the stress associated with just the dead load. If I want to look at the displacement, that's available as well. Let me just quickly hide away those simulation symbols. Now I want to look at it, okay, what if it's independently loaded up with the snow load, but no dead load? What's the equivalent displacement there? Okay, how about with both of them now? I turn on my first combination, and that's both of them. And so I can step through and I've got results for all of these different situations where I've got dead load, live load, snow load, wind load. But I haven't had to go and duplicate, 6 or 7 different studies at the bottom here. It's all within this load case manager. When I come back here, I can simply add more combinations or add more primary cases as needed. Maybe if I want to investigate what happens if I'm looking at the snow load, maybe 150% of the snow load, and I want to see what it looks like with 3 times the wind load. I can type that in, and then I can go and run this again. And I can actually just choose to run the combinations. I don't have to run the primary cases again. All right, so it's going to go through. It's going to take a fraction of the time that it would take to actually run 4 full analyses. And then once it's done, I'll be able to look at those results again in my second tab here. Okay, so that's the load case manager. Again, it's brand new for SOLIDWORKS 2015. If you're looking at different combinations of forces, it works for things other than structural analysis, of course. So please take a look at that. The second thing that I want to take a look at today is submodeling. This is, again, a SOLIDWORKS Simulation Professional feature. What the submodeling tool is going to allow us to do is run an overall analysis and then zoom in on a local region. When we zoom in, we're going to be able to improve the results for that particular region by including more realistic conditions. We can refine the mesh. We can play around with different designs, maybe use specific connectors. But we're going to be able to do that while incorporating the global effects of the overall analysis. So it's going to be a more accurate approach than simply zooming in and using boundary conditions to represent those other components. Just going to switch files here. All right, I've got this example loaded up. Some of you may have seen this before. It's obviously a section of a car suspension, and I've gone and suppressed out some of the components, and I've run an analysis. I fixed the far ends, a few locations. I've placed a force pushing on the steering rod, and we're concerned about the stresses in this bracket. So we can run this analysis, and it's fairly large. There's a good number of components here. It's nothing massive, but it's not small either. And we can take a look at the results. Now, I haven't done a perfect job of representing this realistically. If I'm concerned about this bracket, one of the key things that might be of concern is how it's connected to the knuckle. And of course, it's bolted together. In my model here, though, I've simply represented these two components as being connected with a bonded connection, so I've glued them. So not a full realistic representation. So what are my options? Well, I could come back in and I could switch my contact condition at that location with a local contact set, and I could set that as a no penetration contact. but that's going to greatly increase the solution time of my analysis. Also, if I take a look at my mesh here, my mesh quality on this bracket isn't very good either. So I'd want to refine the mesh. Again, I could go and grab a mesh control and refine the mesh for that bracket, but again, my solution time is going to increase. What we're going to do here is we're going to take a look at what the submodeling tool does, and it's going to allow us to improve the results, but without having to run the entire analysis again. If you're in a SOLIDWORKS stress study, once you've done your overall study, what you can do is you can right-click and you can tell it you want to create a submodeling study. When you do this, it's going to pop up with a number of different rules that you have to follow. Basically, they're telling you the advantages of submodeling and then when and where you can use submodeling. With all these different rules, it can be a little bit confusing. I'll leave it to you guys to read through that. The big takeaway from this is that anywhere where you split up from your overall study to your submodel study, where you zoom in, it has to be a bonded contact. Right? It can't be no penetration. It can't be beam-to-beam contact. It has to be bonded contact. If you're okay with that, you simply click OK and select the parts that you want to include in your submodel study. Right? So I include the knuckle and the bracket. Now once I click OK, it's going to create a derived configuration in SOLIDWORKS and then create an additional submodel tab at the bottom. Now I've already done this, so I'm going to switch over to that one. And you can see in this study, it's a separate configuration created as a derived configuration in SOLIDWORKS. And there are just two components. Now I'm just going to pause here for a quick second. Looks like I've got a question come through, so I do want to just take a quick look at that. Let's see. Got a few questions. Okay, so first question, can we get a copy of the PowerPoint? I'll see if I can get that over to you guys afterwards. I'll be able to send it via email. Second question, for the load case manager, can you combine different types of studies such as thermal? No, it's not going to be available for a thermal study. Okay, continuing on with our submodel here. I've selected two components and I've created that sub-configuration that only has these two parts. Now, in here, I've come in and actually improved my analysis. I've defined that no penetration contact set between the bracket and the knuckle. And I've also included bolt connectors between the two. So now I'm actually looking at an accurate representation of the behavior between these two parts. However, I haven't ignored the global analysis that I did. Right? Instead of fixing these holes at the top and bottom, I've actually got displacement from the parent study. You'll notice there's no force on this analysis. Instead, the force is coming from that steering rod that was in the previous analysis, but it's being driven straight into this via these two faces. I've also defined some mesh controls and used a smaller overall mesh size, so you can see I've got a much improved mesh shape on both the bracket and the knuckle. And so I can go and run this analysis, and it's going to be much faster than if I had done these no penetration contact and bolt connectors on the overall analysis, but I'm still going to have results that are respecting the overall global conditions. All right, so it's a happy medium where I can get more accurate results, but I'm not taking as much time as running these detailed components on the full part or assembly. Okay, so that's the submodeling study. I definitely encourage you guys to use that anytime you have something that is large and you want to take a look at a particular region without ignoring the overall effects. The third feature that I want to talk about today is something called the trend tracker. The trend tracker is included in SOLIDWORKS Simulation Standard, Professional, and Premium, so all 3 simulation packages. And the key thing it's going to allow you to do is to track your results as you run your study multiple times. This is going to allow you to make changes and see the effects of those changes, and it's useful in 2 main situations. The first situation that I really strongly encourage people to use this for is when you're checking for mesh convergence. We know that the accuracy of our simulation results, particularly stress results, is highly influenced by the quality of our mesh. And even though we know this, a lot of us don't go through as many iterations as we should checking for mesh convergence, partially because it's inconvenient and time-consuming. The trend tracker should hopefully help you make that process a little bit less time-consuming and provide you with a graphical way to make sure that you're finalizing in on that correct answer. The other thing that you can use this for, and this can be useful, I don't use it as much for this, but it's definitely a good way to use this tool, is to compare different design options. Right, so this trend tracker is going to track your results regardless of what changes are made. So if you want to see what happens if you make a part wider or if you make it thicker, it's going to be able to show you those results as well. So I've got a pretty simple take in the simulation training course. You'll recognize this support bracket. I've set up a very simple analysis. The part is currently cut in half, so I am using some symmetry to speed up my results. I've fixed the back face, I've got my symmetry restraints on the 2 cut faces, and I've got a force on this split line face. And I've meshed the part with the default mesh size and run it and got these results. Now we know that mesh convergence is something that's very important for the accuracy, so the next step here is to refine the mesh and run the analysis again. There's a few different ways that this can be done. One of the most common ways that we often teach in our training courses is to simply duplicate the study. Right? Maybe create a second one called static 2. At this point I can refine the mesh in my static 2 study, and I can run it again, and then I'll be very easily able to switch back and forth and compare the results. All right, so that certainly works, no problem. After doing static 2, I might create static 3, static 4, and compare all 4. Another thing that you can do is you can just work with this static 1 study. You can keep refining, and as you go through and you get your different stress results, you can just simply write them down on a piece of paper and make sure that they're converging on a final value. I've definitely seen people do that. Some people have used Excel spreadsheets to track it. If you're getting a little bit fancy, you guys may have been using adaptive meshing, right? We've got our 2 types of meshing, H-adaptive meshing, which is going to use mesh refinement, very similar to how we would manually. It's going to place more mesh elements in areas of high stress gradients, and it's going to place in areas where we don't have large gradients. Or you can use your P-adaptive, which is going to up the, so take it up from a 2nd order to a 3rd, 4th, or 5th order element. Right, so those can be done as well, and that's an automated process. But when we're going through manually here, using the trend tracker can allow us to go through all in one study, so we don't have to duplicate 1,000 at the bottom here. And it's also going to give us a graphical representation so that we don't have to go and record it in Excel. We don't have to go and write it down on a piece of paper. To activate this, I'm going to rename again. I'm going to turn on the trend tracker. And at that point, I'm going to take this current study and I'm going to use this as my baseline. So this is my first analysis. I'm going to tell it to add an iteration to the trend tracker. It's going to save my model, and now that value is recorded. All right, so my value of maximum stress was 215 megapascals. It's got that point right there, and now I can go and change my model. So I'm going to refine my mesh. I'm going to grab a mesh control, going to select these two faces since that's where my high stress locations are. Sure, let's use mesh control of about 3 millimeters. Let's see what that looks like. I'll go and create my overall mesh again. Last time I used 6.14. Let's just take that down to a nice even 6. All right, slightly more refined. I'll go and run my analysis. And when I run it, it's going to prompt me and let me know that, hey, I'm saving a new iteration to the trend tracker, which is exactly what we want. And so now if I come and take a look at the stress trend, we can see, all right, it was here, and now it's moved up on iteration number 2. Let's refine a little bit more. We'll go find that mesh control. Let's edit that. Let's take that down to 2 millimeters. And then let's go and do an overall mesh size, maybe 5 millimeters. Right, so I'm refining a little bit more. Going to run that again. Save another iteration. Now when I activate my stress plot, okay. Looks like that's leveling out. We better do one more just to be sure. I'll come in here. Let's do 1.5 millimeters. I'm going to go to my overall mesh size. Let's set that at 4. And run it one more time. It adds one more iteration, and now I can come back and look at my plot and say, uh-oh, okay, it's jumped again. Maybe I need to do a 5th one. And I do eventually want to see this leveling out on some final value, and at that point I can be confident in my results and be certain that if I have inaccuracy, it's not due to the quality of my mesh. You'll notice it also tracks other values, right? Tracks my displacement. The change for your displacement will usually be relatively small compared to stress, right? Certainly not subject to the same changes due to mesh quality. And then it's also going to track your mass. Now, I haven't actually changed the geometry of my model, so of course this is level. But again, that's the second thing that you can do here. I can come back to my model and I can make changes. So maybe I want to see what this thing looks like if the hole is a little bit bigger or a little bit smaller. Right, I can grab that value, type in a different value, remesh and rerun the analysis and see what that does to my stress or displacement values. So I think the most useful thing for this tool is to use it to check for mesh convergence, but it also works really well for tracking geometric changes. The only trick there is you'll have to remember what geometric changes correspond to which iteration. Okay, so those are the 3 tools that I wanted to go through today. They're all very simple to use. It's really just a matter of loading them up and trying them out. Remember, it's the load case manager, submodeling, and the trend tracker. We do have some upcoming webinars every Wednesday. We've got both our product demo and product education sessions. Next week, we've got a product demo on SOLIDWORKS Electrical, and then product education on SOLIDWORKS Composer, and then the week after, we've got a demo for CAMWorks and some education for SOLIDWORKS Enterprise PDM. If you have any questions, I will be sticking around for a few minutes, so please feel free to ask them in the question box on the GoToWebinar interface. Or if you think of something later on, feel free to give our support team a call, either by phone or you could send in an email. Other than that, thank you very much for sitting in on the webinar today. Hopefully I was able to show you something useful and you'll be able to go out and try out those tools. Again, I'll stick around for a few minutes, so please let me know if you have any questions.